presented by the Altorum Leren participants. We from Railway Academy, we welcome you for this interesting webinar. And the webinar is a series of activities we do on every Friday. From Railway Academy, we conduct various signaling courses from basics to the modern technology, including the metro technology. For more details, you may reach us, or at the end of the webinar, we'll just introduce our activities. Not talking more on our academy at present, I will welcome you all. This webinar is a very interesting webinar where I request all the experts from various fields to participate. Kindly go through the presentation done by Mr. Sandeep through this webinar, and you are free to ask the queries in the chat box. At the end of the session, the queries will be answered too. I again welcome all of you, and again welcome Mr. Sandeep to present. Sumit, you can transfer the control to Sandeep now. Over to Sandeep.
So done, sir. Done, sir. Over to Sandeep.
Sandeep, please start.
So done, sir. Done.
Sandeep, please start. Please start.
Welcome everyone. Am I audible?
Yes, yes, we can hear you.
Welcome everyone, and thank you for joining this webinar. So today I'm going to talk more about IoT and how it is going to change the business, what you do, and thank you for joining this way we communicate and way IoT technologies. So in this, today we are going to, the agenda of the meeting is, we'll go about what is an IoT, what is
there is background noise.
All are requested to mute, please. All are requested to mute. Kindly listen to the webinar, please.
So the agenda of today's meeting is what is IoT, what is the architecture of IoT, what's the journey to start IoT. We'll talk about a little bit of artificial intelligence and machine language, and we'll also talk about industrial use cases. before we start with through the history, to tell you about how this industrial revolution happens. So between 1970 to 1760 to 1840, the steam engine was invented. And what happened is that some of the mechanical works were taken up by the steam engine, and the human efforts were multiplied. Then the second industrial revolution happens between 1870 to 1940, when we introduce mass production and assembly line. And one of the very good example of this is by Ford Motors, by Henry Ford, where he started assembling the motors or the vehicles, and the cost reduced a lot, and the vehicles and the cars becomes affordable to common people. The third industrial revolution started somewhere in 1960 to 2010, where there was computers which were simply in the for scientific purpose, was brought to the normal life, and the size and the cost decreases a lot. Today our mobile phone is more powerful than a supercomputer in 1960s or 70s. And the second important revolution what happened is the internet, where everything has been connected. Now, because of these two revolution or advancement in computers or computing power and internet, that gives a set path for an industrial revolution 4.0, which is based on IoT. IoT was coined by 1999 by Kevin Aston, and Germany is one of the company which is leading in industrial IoT. So before we start with the IoT, let's see some of the use cases of the IoT. Okay, so this use case is about cloud-based predictive maintenance of the transformers. So the business problem was that it was so difficult to have a reactive maintenance of the transformer, and because of not giving proper care, the lifespan was reducing, which increases the cost. So there are few parameters which we need to. Transformer already had many sensors, but the thing is that it was there. If you want to get those information, you have to be near to the transformer. But the sensors like transmitting temperature information, moisture information, and the location information, if this information can be made available to the field workers or the office staff, right, then with active monitoring you can really take care of the transformers much well. And this can reduce 35 to 36% of the cost, and productivity is improved. Also for field workers, they don't have to do survey, they get alerts, and then it's much easier for him to maintain it, because it can give you an alert before certain things fails. Now let's go for the second use case. The second use case is for the fleet management, and Okay, the second business problem was, efficient management of the fleet. One was, and to understand the driver's behavior. Uh, and the reason what they want to train the drivers and improve the driving behavior so that it increases the passenger safety, save the cost and geofencing. So with IoT, you can really, you have all the sensors and that data was been sent to the cloud. And then with the proper reporting and monitoring, we are able to, reduce the fuel efficiency and increase the driver's behavior. Uh, Third use case, what I want to present is a locomotive solutions. Uh, then here, what the business problem was, they want to again look into the behavior of the driver, and to also see if, for a reactive maintenance of the locomotive. For example, the first 3,000 hours, they want that once a locomotive runs for first 3,000 hours, then a preventive maintenance should be executed. Sometimes they skip it, which decreases the lifespan of a locomotive. So here, what we start monitoring is the start and the stop time of the engine, and also the oil temperature. And based on the historical information of historical data of the oil temperature, we used to, find a give a proper way when there is a spike in, in temperature, that leads to, driver's behavior. Although we can add more parameters, as we have explained in the fleet management, also in the locomotive, but here it was only the oil temperature, but we can do it more. Both the parameters will lead to predictive maintenance, and we used to send alerts to the maintenance department so that, they can maintain the locomotive. Now, before we go further, let's see what is IoT. I think you have a pretty much idea about, how IoT works, but what is IoT? IoT is a, network of very low powered connected devices who collectively gathers and process the data. So as I told you that in Industrial Revolution 3, we got devices, we are very powerful. Some of them, like your mobile phone is more powerful than the supercomputers of 1960s and 70s, together with the invent of the IoT. So, you have low powered devices, sensors, actuators, and they start communicating with each other and collectively process that data. Now, these devices can be connected either through a wireless communication or wired communication. And some of the methods of wireless communication, it can be radio frequency, sound, wave, or light. And for wired communication, it can be copper wires or fiber opticals. Now, when we are moving in the world where, everything will be connected by a network, right from your mobile phones, even in fleet management, everything will be connected, and this will bring the power of the IoT. And the another development which is happening, which will add more power to the IoT, is the invent of the artificial intelligence. So IoT is mainly connectivity and transfer of message and processing of the message. But artificial intelligence will also bring the intelligence to this network. We'll talk more about artificial intelligence in the coming slides. And the biggest advantage of IoT is that you have a real-time communication without the involvement of the human being. Now I'm going to functionally define how functional architecture of the IoT at a very bird's eye view. I'm not going to go into more detail about it or more technical jargons, but very at a high level how it works. The first thing is that there are different sensors. From the sensors, what we do is we send the data and collect the data from different sensors. Then these sensors are are sent to the gateway, and then gateways further sends this data to either a cloud computing or cloud infrastructure, or to an edge computing. I'll come back to edge computing more with some examples. Now, this is how edge computing is bringing the computing power near to the action, where where connected devices are there. Now, what we do is that once we have the cloud computing, uh, data is represented to the users in a possible actions. So you get a 360-degree view of on all the connected workspace. When I say connected workspace, then about all your assets. It can be all the machines. It can be your fleets. It can be your vehicles. All the sensors, all about your people, all about the locations, every information, 360-degree view you can have from the central command or through a connected workshop. You can take multiple actions also. Now, this data, once it is collected, because you can have millions of these sensors, you get this data, and then this data can be fed to an existing applications, or it can be put into enterprise application. And again, as I told, once you get an insight, you can take a particular action also, actions from the actuators. One of the very good example of to understand what is edge computing and what actions you can take, I'll take the examples of a traffic light. So let's suppose today what happens is that if you have a traffic light, then generally it is manually fed. What will the time for which the red light will be there, what will be the manual time for which the green light will be there, and what will the manual time for orange lights. But if you have a let's suppose a camera which looks into the how many vehicles are there in the particular road, and then edge computing means you have the computing power near to where near to the traffic light, for example. So what it does is that it can take the image, it can at real time process it through an artificial intelligence, and based on that it can determine that it has to wait for 30 seconds or 40 seconds. So it's dynamically reacting, right? So edge computing brings the cloud computing to the edge part. And today we have a lot of GPUs, graphical processing units, which can process the images, and you can take the action where there's a change of the traffic light is an actuator. You actuate based, you give a signal to the actuators, and then it takes a proper action. It changes the if there is no traffic, or even the time can change based on other parameters. For example, if it is what time of the day, if it is on office hours, whether it is a weather conditions, all can be taken care dynamically and taken the decision. That's possible. Now, few other things which is more which I want to tell about this functional architecture is that once the IoT, if everything is being connected, there will be millions and going to billions of devices. Now, to maintain the firmware or the software which is running on that, going to each and every devices is not possible. So there is something called on the air, OTA. So where you can, from the remote location itself, you can update the firmware and the software is running on that. So that's on the air. Edge computing, I have told you that you bring the computing power near to the place of action and not thousands of kilometers away, where into the cloud and processing and return back. So if there is a need for processing near to the place where it is needed, and we cannot wait for to send the data to the cloud and to receive it, you can use edge computing. So next is, if there are so many sensors, actuators, devices, machines, you need to manage them. So, the device management part is very important, configuring them and other things. Now, work and asset management, the locomotive is a very good example of what we do, work and asset management. So, we configured, for example, first 3,000 hours, it has to go to for the first maintenance, then after 6,000. So it was configurable. So what it happened is that whenever this 3,000 hours was done, an automatic, scheduling or assignment of the field agent was done, and an alert was sent to the support team so that they can do the servicing part. So work and asset management is assigning the field agents, scheduling the jobs. Second is the ticket application, where you can have the life cycle of the tickets, and also follow the the SLA. For example, if a certain work has to be done within 2 hours or 3 hours or 4 hours, that's possible, because then there is an accountability that this is a critical operation which has to be done in 2 hours. So the ticketing applications can do it. I think when I'll be talking more about blockchain, I'll show you on one use case where the service SLA, service level agreement, we can implement using blockchain. Then of course you can set different kinds of alerts through either SMS or through email or push notification or any other methods. And the last but not the least, you can get various kinds of operational and governance reports and in the dashboard, or you can export it to get more insight about how your assets, everything is working. Now, next move to the technology stack of the IoT. This is high level how a technology stack work. The first layer is the hardware. The hardware layers, it can be a sensors, it can be an actuators, it can be a microcontroller, microprocessors, PLC, HMI, it can be any hardware. And the complexity of IoT devices is that it can have any kind of hardware, where it can be superpower as computers, or it can be very small with very low consumption. So the amount of complexity is quite high. Now, to work with those hardwares, you need a hardware abstraction layer. Now, what is an hardware abstraction layer? It's a layman term. It's a piece of software where you don't worry about what hardware is there. Now, I'm going to give you an example. Let's take your mouse, what you use in the laptop, right? It can be wired. You can plug in through your USB cable. It can be through Wi-Fi. You put a Wi-Fi USB cable and then it works. It can work through Bluetooth, right? So how this hardware how you interact with this hardware, it is even abstracted, right? And then you provide a consistent interface to your application and operating system, so that you don't have to worry. Either it is using Bluetooth or either it is using Wi-Fi. You don't worry about it. So that hardware abstraction layers, you shield from the different varieties of hardwares what we have. On top of that, you have the operating system or real-time operating system, and it depends. Sometimes it's for example sensors or some of the microprocessors or microcontrollers, sorry, is so small that even an operating system you cannot put it. So this is optional. If it is there, you can put it. Otherwise, it can be very simple application running on top of the hardware abstraction layer. Now you have varieties of services on top of your operating system. So looking from the left side, you have the protocols. Now what protocols? What does protocol means? From a layman terms, it is way we communicate. Just like I'm communicating with you in English, so I know that it has alphabets, it has words. Words makes up sentences, and there is a grammar. So these are various protocols. Now there are multiple protocols, but I have taken 4 of them, which is quite used. First 2 of them are MQTT and QAP. Now, MQTT was developed by IBM, and then it was open sourced. So it's an open source protocol which has been used. It's an application layer protocol when it works on pub sub mechanism. So to explain you what happens is that, any one interesting event, if it happens, what it does is that, let's suppose, the temperature rises, or the CO2 level is increasing, or the oil temperatures is increasing. So what happens, it publishes these events to a broker. We call it MQTT broker. So it receives it, and those who are interested in getting this event, they subscribe for it, and then they receive it, this event, and then they can process further. So that's MQTT protocol. Second is QAP protocol. QAP protocol is for constrained devices, and it's very similar or inspired by HTTP. So you have different methods, like you can create, update, delete, or something like that. Same you can do with the QAP protocol. HTTP protocol is quite. This is how we interact in the internet world, and WebSocket is also works on TCP/IP. So these are different protocols. This is not limited to 4. There are other protocols. Now, second one is FTO, that is firmware update through over the year. As I told you that, if there are multiples, thousands and millions of devices, you cannot go to each of the devices and update the firmware, or update the application. There we have another protocol called OTA, over the year, that helps you to upgrade the firmware. Not only upgrade, but if something happens, you can roll back, and and it checks other things. In security, will tell you that whenever the firmware is updated, how you make sure that security is not breached. Next is security. There is a slide for that where I'll cover this one. Again, then you have thousands of devices, then you need a device management and configuration. You have to configure it. For example, if the gateway wants to communicate to the cloud or to the edge computing, you need the credentials to connect it. So those device managements, all those configurations, that we have to do it. Now, on the right hand side, we have the sensor stacks. Now, there are some wireless protocols or mesh network. When I say mesh network, means each one can send each one. Let's suppose you have 5 people, each one can talk to each one, then that's a mesh network. So, Zigbee, BLE, Modbus. Modbus is not a mesh network. LoRaWAN is a mesh network. So this kind of, you can create and communicate with various sensors, actuators, and PLCs, and get the data. Now we have the other device, which is Cloud Connectivity Manager. So how you connect to the cloud, which can be edge or cloud, how you manage the data, and of course then we have your custom application, which depends on your business requirements. So as I told you about different data communication protocols, then data management, like how to filter the data, how to store it, it should not be lost, all those things have to be taken. Cloud connectivity means, as you know, that wireless communication is very unreliable, so it should take care of resending it if it has been lost, or a timeout, or securing it. And then we have the custom application. Now, one of the most important thing is that if everything is connected, then of course, then you need proper data security. Then there are various methods of how to secure the data and the network. When I say data both in transit and in the storage. The first thing what we can do is device registration. Each device in the network can be registered, or it is known to the register, so that any other device which is not known into the network they are simply not registered and they cannot communicate. So second is you have the checksum and digital. I told you about firmware update. Now if hackers hack it and they put their own application or firmware, and this is a security breach. So to avoid those kind, every time you have you do the checksum is to ensure that because it is the firmware is sent over the air, what we send is what is received. That is what we check, we can check with the checksum. And digital signature is a hash code. It's very similar to you get a certificate, and then let's suppose your Mastercard, then the vice chancellor or signs it and put a seal, then you understand that it is correct. Similarly, we have a digital signature. So a digital signature is created for the firmware, and before installing it in any of the hardware, it checks that the signature what has been created is actually created for an authorized person. So that is used by private and public key. Third is also because, as you know, that the devices are very constrained, bandwidth is limited. In that, messages are compressed so that it can be quickly transferred, which reduces the size and save the bandwidth. We can use various transport layer securities. Another interesting is token-based authentication. What is token? Generally, what happens? Have you used Facebook or something? You log in with your username and password. Once it is authenticated, what it does is that it gives a token with a very small validity period, 5 minutes, 10 minutes, not more than that. That means if someone hacks your token also, it will be compromised for 5 minutes, and it's not so easy to hack that one also. So what it does is that in that token, it's for a limited period of time, and then it gives you what you can do and what you cannot do. For example, in a Facebook, you can maybe you can read others profile, but you cannot make the changes because you don't have the access to it. So token based authentication, we with every message we can put an authentication with a particular access, and then you can make the necessary changes or create or update or read based on if you are authorized or not. And every 10 minutes or 5 minutes, it's configurable token changes. And I think when I'll be talking more about blockchain, I'll give you a use case where blockchain can enhance this token based authentication or authorization. And the last one, but not the least, is of course we encrypt the data in the source, and in the destination we decrypt it, so that even though if someone gets the message, they or interprets the message or intercept the message, they are not able to understand it. Now, how we can implement IoT? So this is a very high level 3 steps process of how we can implement any IoT into any of in any scenarios. First is identification. What does identification mean? Is that you understand your business requirements. Based on the business requirements, you identify the devices that needs to be monitored or maintained periodically. So based on the business requirement, and what devices you can monitor, it can be real point assets, it can be locomotive and their parts, platform, as it's at parking places, it can be anything, literally anything. Second, once you have identified it, you put proper sensors to it to start accumulating the data. You connect those sensors to to a cloud or to a edge computing and starts monitoring it. Now once you get this data, either you can start monitoring it, you can send an alert, you can have a preventive actions, you can have informed information, and of course once you get this data, you can also use AI and blockchain. So next is IoT maturity model. How do you, mature as an organization in the IoT? So initial 0 to 6 months, the first stage is information processing stage. In this stage, what you do is that, you gather the provided information for human to take preventive action, not reactive. None of the existing way of working is being changed. It's just complements whatever you are doing it right now. So of course it is low risk. It brings a high value because you get another insight from, and that is data driven decision you can take. No code design is changed, and of course lower cost of implementation. uh, Second, which takes around 6 months to 2 years, is a hybrid stage. And in this stage, some non-critical designs, we start managing it using actuators and sensors. And of course, the all critical designs will still be managed by human at the back of the information provided. Now, designing this kind of system, it's non-critical, so we can go. It brings an high value for it because you can start automating the things. It has a medium change to the core designs and has a medium cost for implementation. And the third stage is, you have a connected workspace, what I was talking about, the functional architecture. It takes two years or more to reach that. This is the nirvana stage, where everything is triggered by sensors and controlled by actuators. No human intervention is taken. Human resources are still being used to monitor the incidents and take some actions if needed, but bulk of the actions can be done. And this depends on the reliability of the systems. Of course, this requires core design changes in the way we are working. It may also change the regulatory needs of and the approvals. It is a higher cost of implementation because large change is required. Now, this maturity model, it changes the way people work. It will change the process how you work, and it will of course bring new technologies. Now, different types of sensors, although there are a lot of sensors, but we try to tell how you can differentiate between one sensors to other sensors. The first one is active sensors on a passive sensors. What do you mean by active sensors? Active sensors means sensors where you need external energy for any kind of measurement, whereas passive sensors use their own energy powered by battery. The second is based on conversion phenomena. That means, you convert, you get information in one form and then you convert it into a different type. For example, thermoelectric sensors, electrochemical sensors. Third one is based on means of detection, right? These sensors detect a single parameters based on what they detect. For example, electric sensors, radioactive sensors. And the last one is analog and digital signatures. A digital sensor detects one of the two states value, either 0 or 1, while an analog sensor detects a proportional value between 0 and 1. So these are broadly different kinds of sensors. Now, one interesting thing about the IoT. Now, when we converge AI, that is artificial intelligence, and IoT, it is called AIoT. While IoT is the digital nervous because it provides the communication, it provides the communication channel, it secures the communication. It can be think of our nervous system. It sends information. If something is burning in your hand, it can bring it to your brain, and AI can, it becomes the brain which controls the system. I want to tell one thing is that, AI today, there is a tremendous advancement in AI, but it cannot replace till now human being, because human being is capable of doing multiple works. I can cook, I can I can code, I can design, and I can learn new skills. But today what AI does is a single task. So if it is good in controlling and knowing about traffic lights, then it is for that one. It cannot do anything else. So that's the limitations. But with the advancement we can get human replica, but we are far away from there. Now, with the rapid advancement in both the fields, enable devices to be proactive. That means it is not dumb anymore. It is proactive. You can react it based on artificial intelligence. Now, one of the thing is that generally IoT devices are connected to a cloud platform. Why cloud platform? Because just like a child, uh, you create a model. And what is model? Model is kind of an algorithm. To teach that artificial intelligence, you required a lot of data, and that's why this is a very good marry between IoT and AI, because IoT can collect lot of data, and that can be fed into into AI to improve uh, the the models. And of course, because it requires a lot of data, it requires a lot of computing power also. And because it has to be trained with a lot of data. Now with cloud computing, what has happened is that computing and the storage power has come down considerably. I think previously the having a data center or a cloud is a privilege of big organizations. But even a startup, even an individual can go to to any of the cloud providers, have a click, and within fraction of the amount what is needed to create a data center, you will get the computing power. So that makes AI one of the reason of the advancement of AI is this one, cloud computing. Now, how AI works in the sense, you can think of AI as a child. What it does is that if a child, you'll tell don't touch this one because something is hot, it will burn your finger, right? So and then you tell children that this is cold, if you don't if you touch it, it will not burn it, but you will feel cold sensation in your skin, right? And then child keeps on learning about from it. Okay, this is hot, this is cold, this is normal temperature. They develop the sense. So here in AI also, what we do, we create a model at a high level. When you say model, it's kind of certain kind of logic or algorithm, right? And then what it does is that you feed this data, this model with a lot of data. It's something like a child. When it is growing, it's fed with a lot of data from parents, from teachers, from environment, and then it processes and try to understand it, and it improves its model. It's very similar to that. You make appropriate uses of this technology, can perform auto correction, take decision on its own, right? Now so so once, let's suppose let's take an example of the time scheduling of trains, right? If you train them, create a model and train them, then that it can do that particular piece of work quite fast, in the sense and with accuracy. This reduces the time. It can be for any other purpose where it's a manual kind of work, or it requires, sometimes it is beyond the human capacity, because you have to process it very fast. So there artificial intelligence can be used. Now artificial intelligence is used in a lot of places. That fleet management, what I have told is that it collects various parameters from the fleet, oil temperatures, oscillator, how it is driving, the speed, and all those information are fed to a model, and it can predict how this driver is driving. And then you can train your drivers accordingly based on this feedback, right? Now Another interesting aspect which is developing is for the industrial IoT is blockchain. So few things are very important for me. So if someone knows, it's good, but I want to repeat few of the things. What is blockchain? You know about accounting, right? Ledger, debit and credit, any transaction. Blockchain is a distributed ledger. Distributed means no one single person will be having no, anyone who is part of the network can access those ledgers, right? So it brings trust, not security. So I'll tell you how to build security on top of it. But that means, how it brings a security. I'm giving a bird's eye view how it happens. Let's suppose you have a transaction 50 rupees transferred from A to B, right? This is the transaction. This is, we put it in the ledger. What we do is that we using a cryptographic method, we find a digital signature, a hash of this, right? And we append the hash and the transaction to it. Now, let's suppose in this ledger itself, I want to give 20 rupees to C. So what I do, I have the transactions, pay 20 rupees to C, right? I find again the hash of this, and I take the hash of the previous transaction and again rehash it. So that is block. Each transaction is a block and you chain it. So as your chain become, from 1, 2, 3, 4, 5, it becomes very difficult to break it. Why it is difficult to break? Because the computation power, what you need to break it. And when I say break it, let's suppose I want to change that 50 euro, which is transferred from A to B to 1,000, right? Then I have to break everything, so it is based on the computing power. It requires so much computing power. That means, you cannot, the cost of breaking it is higher than what value you will derive by breaking it. That's how most of the blockchain is there. But what I'm talking about, this is based on IOTA, which is a very good blockchain for IoT based of application. It's not based on, it's based on acyclic or directed acyclic graph. So it's a variation of what I was telling. In this kind of, what it does is that it takes two previous transactions, not all of them. It doesn't make the chain. It takes previously transactions, and then it takes the hash and that's created. Why we need that one? First of all, if you go to Bitcoin or any other things, there, as the chain becomes very large, the computation cost becomes much higher over the time. That's not the case with IOTA, right? And that's why, because these are constrained devices, they are low power devices, and that's why we don't, it has to go faster, and the scalability should be high. That ledger is called Tangle. Now, any transaction blockchain, if you do, it is you require to pay a fee. But in this case, you don't have to pay fee, but there is a catch. You have to have, fee is not there because you have low cost, devices which forms part of your network. But it doesn't mean that you don't have to pay for, finally someone has to pay for the network, right? So in general, transaction cost is not there, but of course it has. Now there is some concept called coordinates. Coordinates is kind of an artificial intelligence which can train the IOTA model, so that it can safeguard you against from the attackers. Because I told you that in this kind of blockchain, right, the two previous transactions have been taken, and then those hashes are taken and to create the blockchain. That's why it's much faster than any other blockchain like Bitcoin or Hyperledger or anything, right? And what happens is that LoRaWAN is one of the network. Building an omnipresence IOTA is almost impossible in this case one. So it's a very good use case for IoT. Now, there are two things which I want to talk about where blockchain can be used. Although the most common use case is cryptocurrency, but let's suppose SLA, service level agreement. There is something called smart contract. I was telling about, if you want that is a priority one ticket and it has to be solved in 2 hours. And if it is not, then a penalty has to be given to a vendor who provides the support. That's the simple contract I want to. With blockchain, you can do it, right? Uh, Blockchain also, I told you that, there is, you can give an identity to each of these devices. And because it brings a trust, I told you how it brings the trust. If you have the network, of all those, devices, you can bring that, you can trust the devices, and then you can exchange it. There is something called SSI, self-sovereign identity. There we can use it for this purpose. There are many other use cases where we can use it. Can be used for manufacturing, it can be used for pharma, it can be used for cement and mining industries, it can be used for food and beverages, it can be used for transport and logistic. COVID-19 situations, you can take it. It can be connected to PLC HMI integration for remote monitoring, and it can also have a security services. This is not limited. IoT can have multiple use cases. Yeah. I can take up your questions.
Thank you, Sandeep, for excellent presentation. And as we planned, it is within the time scale or time margin you have presented. I would request your supporting team or you to take the different questions, whatever are presented. Any one of you can just repeat the questions and give the solutions for that. Can you tell me to whom I have to unmute?
I assume that when you're telling proprietary network, then it is it's a private network, or because even AWS and other cloud providers provide MQTT brokers where we can use it. It depends how much it costs to install IoT for traffic management system, and let's say use 100 junctions including the hardware and the software. It totally depends. The cost of the hardware is decreasing over time, and it will decrease more. How sophisticated you want to build, the cost will depend on that. How reliable you want to work. For example, you want to use let's suppose GPU. I was telling about the processing of the images. Now you can process the image in CPU, or you can process those images in GPU. GPUs are special graphical processing units in the sense. Now the prices of the GPUs is 10 times more than CPU. So hardware cost also increase. For example, how much reliability you want. You don't want to fail. It should run 24/7, 365 days. So it's you cannot put a price on it. It depends on the business requirements and how much it is worth. Uh, but compared to, for example, 10 years back, prices are decreasing and it will decrease more.
Yeah, Sandeep, one question here.
Yeah.
Few people are from railway industry. We would like to know how best the IoT can help us. In the sense, we use already the data loggers. Data loggers, as we had a webinar on the last week, where the data loggers are in the network. They will send the messages to concerned people. How do you think that it is better than what we use the data logger? Of course, it is confined only to railway application, not mainly what we use here. How you can provide the solutions to different maintenance problems?
No, MQTT is not a transport layer. It runs on top of TCP/IP. I think it's been answered. You can run over the UDP also.
Can you come back to my question, please? How best you
MQTT
can?
is machine to machine, M2M. Any other question?
Yeah, I was asking the many participants are from railway domain. So how best you can help us to identify the maintenance activities and the failure activities on the part of human being? How best it can happen, especially for the railway applications. Maybe it is a rolling stock, or it may be a signaling, or it may be electrification, or it may be concerned to the railway track maintenance and the different failures occurring on the railway infrastructure.
Yeah.
How you can help?
How IoT is different from SCADA, I'll leave Birender to answer. In railway, predictive maintenance can be done. Yes, it can be done. For example, I gave you the locomotive. You can have various parameters. You can look into it to enhance the life and reduce the cost. You can track all the assets of the Indian Railway. You lost good amount of substantial amount of money because of theft, so that's also possible. And there are multiple other ways of predictive maintenance which can be done.
Okay, thank you.
I didn't understand your question. Term coined is IORT. Can you please elaborate?
Mr. Madan Mohan Mishra, can you elaborate the question, please? I'm unmuting all so that people can talk.
Sir, it's not the question. It's just the thing that the term is coined as IoT, Internet of Railway Things. Nowadays, people are using it in many countries. That's what I wanted to share.
He was asking what is the elaboration of IORT. Yeah, I mean, somebody from Galaxy 30 is asking the question. Either you can put it in the chat box for which they will answer. Yeah, 1 minute. I will do it. Just a minute.
Yeah, I think Sandeep is not able to hear to your question. The point is around introducing IoT in railways. There is a lot of requirement or
One of the challenge what we face is not related to technology, but the understanding of the clients about what is IoT and how it is going to help. So that is one of the the challenges. And how can we take care of it? I think knowledge sharing is one of the good thing, because I think India has missed all the industrial revolutions, or at least the last one. Uh, if you have to catch up, India should embrace IoT 4.0, so that our industry, our business become as efficient as others, or maybe more than that. So I think that is one of the thing. The other thing challenges are that we don't get it from others is use of different sensors, uh, the accuracy level what we have to get it. So those things are also challenges for it, because in some of the devices the amount of memory or amount of computing power is very less, so that makes it very challenging in the sense. And it's rewarding also as a as a technocrat or as a technology person. So you solve those problems, you feel really good.
Okay.
Thank you very much.
Yeah, I think the most of the questions are over here. Let me conclude today. In the series of the webinar, next Friday, we are hosting a webinar on evolution of metro signaling from two-aspect signaling to moving block.
Rail passengers, there are the health of the locomotives, that is one of them. The health of the rails, because for detection of the cracks and proactive actions on that. uh, you know uh, uh, Means monitoring the behavior of the drivers, not to punish them or something like that, but to improve it, right? That's possible. So once you have the rails are safe, trains are safe, locomotives you can look into, right? Smell you can detect, you can have many other things which is possible to improve the rails. Not only rail, but you can improve the ambience in the platform also, by various ways of doing it. See, the main thing is that you get the data. Once you get the data, you have an information about it. Once you get the information, a proper action can be taken. That's the first thing. In the sense, what IoT does is that it gives accurate information about what is happening, whatever you want to track. So once you have this data, then you can use multiple ways to improve it. Right?
Yeah, Sanjay, I think that brings the end of the session today. Thank you very much. Thank you, your team, for excellent presentation. Let us wait for the next webinar on the same platform on evolution of railway signaling from two-aspect signaling to metro technology, the moving block technology, by Dr. Goundan on next Friday. So thank you very much for all. To kindly reach the team, the company team, message, you please share your mail ID so that the people can, you are already sharing it. Thanks for that. The people will reach you for different services, what they want. Thank you very much, Sandeep and team. Thank you.
Thank you. Thank you.
Thank you.